Okay, so hello everyone. For this video, we are going to learn about differentiability and continuity. So, uh, I copied sa sining statement because amo niyang ginhambal about sa differentiability and continuity. One of the author naghambal sa sininga statement. Continuity and differentiability is one of the most important topics which helps students to understand and the concepts like continuity at a point, continuity on an interval, derivative of a function, and many more. So this topic has already been covered sa aton nga previous nga semester. So about sa continuity and discontinuity. So we are going to relate that discussion or that topic sa aton nga subong nga lesson. So derivative of functions in many more. However, continuity and differentiability of functional parameters are very difficult. So for this discussion, we are going to have example and let us try to make this lesson simpler as possible. So consider the function nga nakapresent dere. So we have okay, so ang aton nga function nga given diri is a piecewise function given kita x plus 3 if x is less than or equal to 0 and consider the function x if your x is greater than 0. So this is a piecewise function. So if we are going to inspect the function, we would find out that for any point on the real number line, so bisan ano lang ang value of x, in a number line, this function will be defined. So, any value of x nga substitute nimo from the number line. So, from the real number line, so may era ka specific nga values ng imong function. However, it can be seen that the value of the function x at equal to 0 suddenly changes. So, uh, if lang tawon nimo dire, kung halin ka diri sa 0 sa ating nga graph. So, from that point, gamit kasing isa ka equation and then pag mag-greater than to 0 or less than 0, ma-shift ka naman sa another nga point. So, from this one, may ara ka duwa ka graph sa or duwa ka equation sa mga graph. So, kung tanawan nato, may ara kita jump discontinuity. So, this is to signify nga may ara kita discontinuous nga function. So, it can be seen that your right hand limit, so if inspect naton, will not be equal sa ating left hand nga limit. So, go back sa aton nga discussion sa continuity and kabay pa nga magamit ninyo diri kag ma-apply ninyo ang knowledge about sa continuity. So, it implies that this function is not continuous at x is equal to 0. So, in simple nga words, we can say that the function is continuous at a certain point if we were able to graph it without lifting sa aton nga pen. So, for example, may ara ka isa ka graph kung ma-move mo siya sa imong graph as dire-diretso lang like straight line so that is continuous at a certain point. So, if you have graph nga sine wave function, for example, nga naga-curve, so kag wala ka nag-lift sa imong mga pen while graphing it, so automatically that function is continuous. So, amo lang mo na ang simple nga basihan of your continuity of a function. So, just a simple reminder lang or review about sa continuity of a function. So, mathematically speaking, a function is said to be continuous at a certain point if your limit from or the left hand limit exists. So, take note, yung mga left hand. Okay, so your left hand limit exists. Same also with your right hand limit. So, dapat ka-exist man ang right hand limit. And this left hand and right hand limit should be equal. So, in that case, kung na-satisfy ta ni siya nga condition, our limit exists. So, ang imong value of x as it approaches from the left and from the right should always exist. Kag dapat equal ang imong limits. Okay, so medyo familiar ito sa continuity. How about if we have differentiability? So ano naman yung bot silingon kung may maghaba kita differentiability. Okay, function of x is said to be differentiable at a point x is equal to a, for example, if the derivative of your f prime a exists. At every point on its domain, it is given some okay, it is given sang formula nga ginagamit naton for delta method nga formula which is uh, f prime a is equal to limit as delta x approaches 0. So meron kita equation nga f x plus delta x minus f of x all over delta x. So based ni siya sa delta method. So for a function to be differentiable at any point, so in its domain, it must be continuous at that particular point, but vice versa is not always true. So para maging differentiable siya, dapat continuous siya. Pero not all continuous functions are differentiable. So we are going to present some mga examples about sa differentiability and continuity. So let's start with mga example naton para mas maintindihan naton. Okay, for our first nga example, we have a function of x. So we are going to increase the thickness ng aton nga. So we have function of x is equal to so x squared plus x. So plus x. Okay, so for example, we are given with the equation function of x is equal to x squared plus x plus 3. So we are going to find out if it is differentiable or not. So if we are going to inspect its continuity, then we could conclude na diretso that this is continuous. So take note that all polynomials are continuous at a certain point. So that this one is continuous. So for its differentiability, so let us inspect. So we are going to use the delta method. So sa pag find out kung differentiable siya or hindi. Okay, we have so given kita sang sining nga function, so we are going to start by substitution lang ng di by y para diretso na kita. So, ang aton nga y will be substituted sa y plus delta y. So, we will have y plus delta y. Ang aton nga x will be substituted by x plus delta x squared plus ang aton nga x will be x plus delta x. Then, copy ta lang ang 3. So now we have to expand sa aton nga expression or to perform mathematical operation para ma-express tani sa mathematical form. So we will have y plus delta y is equal to x squared plus 2x delta x plus delta x squared. Copy ang plus x plus delta x plus 3. Then now we are going to combine sa mga like terms para mas okay, we have okay, combine like terms we will have so x squared. So kung may pwede ka ma-combine, combine mo kung wala so maintain the equation. So may kita ma-combine, wala man pares ang x plus delta x, wala man pares ang delta x squared, wala pares ang x, wala man pares ang delta x. So as is na kita sa nga function. So, now, after nato na simple or na-expand na, or na-expound ang ating equation, so we are going to subtract sa ating original nga equation. So, we will have subtracting sa ating original nga equation, which is y is equal to x squared plus x plus 3. So, subtract naton aton nga mabiling nga equation will be, so subtract this one, this will be, so aton answer will be delta y is equal to 2x delta x plus delta x squared plus delta x. Okay? So, subong, after sini, we are going to divide both sides ng left kag right side of the equation by delta x. So, dividing by delta x, we will have, okay, so now, mabilin sa aton, so pwede ito na express into dy dx na lang diretsyo. This will be, so divide natin ang delta x, so we have 2x na lang mabilin dere, plus delta x, then plus 1. Delta x divided by delta x is equal to 1. Then we are going to find the limits ng aton nga function. Okay? So, find natin ang limit para mag... Okay, so just a correction, wala pa kita naka-apply limit, so hindi pa kita makabuta ang dy dx. So, we have delta y, delta x pa na dere. So, after magamit na kita sang limit, we will have limit as delta x approaches 0. So we have 2x plus delta x plus 1. So this will be dy over dx. So for our answer, dy over dx is equal to, so substitute kita 0 sa delta x, ang mabilin will be, so this will be equivalent to 0 na lang. So we have 2x plus 1. So aton answer will be, this is the derivative of our equation dy dx naton is 2x plus 1. So uh, we know nga ga-exist ang aton nga derivative sa aton nga equation. So if we are going to graph sa aton equation, we would have a graph sa equation nga since ang aton nga equation is polynomial man. For example, you have a graph. Okay, so if we are going to find the values of your function of x or sa aton nga equation based sa certain values of x kag y, so we will have this one. So for example, we have negative 2, negative 1, 0, 1, 2 sa values ng x. Kung i-substitute mo na siya sa aton nga equation, so ang value of your function of x will be, so diretso ko lang dali because I have already the values. But you can solve kung gusto ninyo. We have 5, we have 3, 3, then we have 5 and 9. So, okay, so if you are going to graph or plot sinisimong equation, we will have, so negative 1, negative 2, 1, 2, okay, so kung i-graph na siya naton, so we have negative 1, negative 2, positive 1, positive 2, and this is 0. Negative 2 naton, we have 1, 2, 3, 4, 5. So we have 2 is to 5. Negative 1 naton is for 3. 0 naton is 3. 1 naton is 5. Then, aton nga, 2 is positive 9 for example. So we have this one. So if we are going to graph the function, so we will have sa amo nga graph for example. So this is continuous. So kung tanawon naton, ang aton nga graph, okay, will be this one. So we have a continuous nga graph. So at point for example nga negative 2, 5, so makita na natin ang slope. So we will have, so okay, wait again. Okay, so I will zoom in. Okay, sa sini nga point for example, this is 2, 5. So pwede na naton pangitaon ang slope sa aton nga equation based sa aton nga different derivative nga value. So ang derivative nga nakuha naton is f prime x or aton nga dy dx is equal to 2x plus 1. So kung pangitaon nimo ang slope sa sini nga point sa aton nga graph, pwede naton makuha ang ina nga slope by substituting lang sa value sa aton nga x sa sina nga graph. So for example, ang slope sa sini nga point sa sini nga point sa graph naton will be, so this is ang ari nga point is 2, 5 based sa aton nga coordinate sa babaw kagina. So we have negative 2, 5. So kung is substitute nato or pangitaon nato ng slope, this will be, substitute kita sa negative 2 dara, so we will have 2 times negative 2 plus 1. So this is equal to negative 3. So ang slope gali naton sa sininga part sa aton nga equation sa diri nga part will be negative 3. So for example naman, we have sa diri sa positive 9 and 2. So ang aring nga function will be positive 2 and 9. So kung pangitaon nato ng slope sa sinang part, so pwede naton i-substitute liwat. So we will have same lang Japon nga function. So slope will be equal to, so 2 times positive 2 plus 1. So this will be equal to 4 plus 1. So this is equal to 5. So makita mo man lang ang slope mo at a certain point is i-substitute mo lang man sa aton nga value of your derivative. So, if based sa aton nga ginsuma, we can conclude that the function is differentiable. So, wala man kita break sa aton nga graph. So, nagdire-diretso ang aton nga graph. So, both silingon the function x squared plus x plus 3 is also continuous function. So, and take note nga the continuity bilas ang polynomial function. So at any or at every real number, kaya continuous gid ang polynomial function. So that's it para sa aton nga unang example sang solving for the differentiability sang functions. Okay, let's have another example. So we will have, okay, for example, you are given sang equation, okay, function of x, for example. A function of x, for example, is equal to square root of x minus 5. So, amo ni ang given natin nga equation, x minus 5. So, function of x is equal to the square root of x minus 5 to determine if this is differentiable or not. So, simply lang, first, we are going to substitute y with that y plus delta y and x with x plus delta x gamit ang delta method. So, we have y plus delta y is equal to square root of x plus delta x minus 5. Okay? So, hindi naman kita maka-expound pa sa ating equation. So, pwede na kita magdiretso subtract sa ating nga equation. So we will have, so subtract kita sa ating original equation, which is y is equal to square root of x minus 5. So, again, subong sining nga example, siguro medyo ma-challenge kika mo sa rationalization or sa mga equations with mga square root ng mga equation. So, okay, so, okay, so let us continue. So, diretso na kita, subtract na kita. So, we'll have, diretsohon na lang natin. So, we will have y plus delta y is equal to isang po. Now, we'll have square root of x plus delta x minus 5. So, this will be minus square root of x minus 5. So, since hindi kita maka-simplify and then wala man kita sang pwede dira mahimo, so pwede na kita ma-divide kita diretso by delta x, diretso na lang natin divide by delta x before kita manipulate sang equation. So this time medyo nagsakit na gid ang aton nga equation. So the best way is to rationalize ang aton numerator para makuha naton or madula naton ang aton um, nga ang aton radical sign sa aton numerator. So, in order to rationalize this one, take note of the symbol dari or the sign dari this is negative. So, dapat multiplyan mo lang siya sa same nga function sa babaw nga numerator but with a different nga middle term nga sign or dapat na positive na. So, multiply lang kita by, okay, multiply kita by, so, rationalize ang numerator. So, we'll have square root of, copy lang, x plus delta x minus 5. Then, ma-change lang ang sign. We have plus. Then, we have square root of x minus 5 all over. So, para hindi mag-change na ating function, dapat kung ano gin-multiply nimo sa numerator, amo man na i-multiply sa aton nga denominator. So, we'll have square root of x plus delta x minus 5 plus square root of x minus 5. So, now, pwede na natin madiretso ang aton nga process. So, since nag-rationalize kita sa babaw, so this will be a perfect square binomial na. So, square mo lang first term, square mo ang second term. So, since pareho sila naka-radical sign, so madula lang ang radical sign sa first and second term natin. So, we will have y plus delta y is equal to, okay, so take note lang ang madula na nagiling natin nga y kaya minus. Nakita sa mabili na lang diri sa kilid, we will have um, delta y over delta x na lang. So we'll have delta y over delta x is equal to, so we have square nato ng first term, so mabilin is x plus, so delta x minus 5 minus, so pasulod na naton x, so masulod man ang negative, so that will be plus 5. So, all over sa aton nga denominator, which is multiply mo ang tatlo or pwedeng i-copy natin ang tatlo. We will have delta x square root of x plus delta x minus 5 times or plus square root of x minus 5. Okay, so after sini, we are going to find the limit na. So find the limit as delta x approaches 0. So we will have, okay, so dy over dx is equals to the limit of sa siningay function as delta x approaches 0. Okay, we have x plus delta x minus 5 minus x plus 5 all over. We have delta x multiplied by the quantity square root of x plus delta x minus 5 plus square root of x minus 5. Okay, so we have this one. So take note nga sa atong numerator, pwede mayara po kita pwede ma-simplify. We will have, so 5 kag negative 5 will be cancelled. Negative x plus negative x will be cancelled. So delta x and delta x will also be cancelled. So ang mabilin sa babaw, before kita mag-substitute sang value will be, so we will have 1 all over square root of x plus delta x minus 5, so multiplied by square root of x minus 5. So substitute nato ng 0 dire sa aton nga delta x to find the limit. So ang mabilin, we have 1 over square root of x minus 5 plus square root of x minus 5. So parehas lang muna sila square root of x minus 5. So pwede natin sila i-simplify as 1 all over 2 square root of x minus 5. So this now will be the values ng aton nga derivative. So amo na ni aton final answer kung ang ginapamangkot sa imong derivative using delta method. Okay, so amo na aton value for the derivative of the function. So, but if ang ginapamangkot sa aton is if differentiable siya or hindi. So, in order to find kung differentiable siya or hindi, pangitaan mo ang sang value nga kung sa diin mag-0 ang imo denominator or diin siya mangin hindi differentiable. So, take note that um, sa point nga or sa part nga, ang imo value of x, for example, x natin will be equal to 5. So kung amo ning substitute naton dere, aton function will be undefined because ang magwa sa aton nga function will be mayara kita 1 all over 0. So undefined siya kay 5 minus 5 it will be 0. So hindi siya mangin differentiable. Okay, so may ara point nga hindi differentiable ang aton nga equation. So that's it para sa aton example for continuity and differentiability. So more examples will be uploaded ng soon or para sa aton nga Google Meet sa or sa Zoom naton nga meeting. So we will have more discussions about differentiability and continuity. So thank you everyone guys. Stay safe. God bless.